in order to practice further this idea of Fischer projections and the determination of the absolute configuration R and S, let's take more examples. Now, we learned before, of course, that we can determine R and S configuration on Fischer projections by either holding one group fixed or steady, then rotation either clockwise or counterclockwise, or by doing 180-degree rotation, which is allowed. Let's do both, actually. So if we have something like this, let's try to determine R and S configuration here following the two methods. Okay, so let's hold one group fixed and then we rotate clockwise or counterclockwise. Of course, that is only if the lowest priority group is not at the top already. So the lowest priority group here is actually hydrogen, so that's number 4. Bromine is number 1. Nitrogen is number 2. Carbon is number 3. So these are the priorities based on atomic number. Now, what we need to do is we need to rotate the molecule in an allowed manner, if you like, so that the lowest priority group is at the top. We can do either the original method, which is, or the first method that we learned, and that is to hold one group fixed or steady and then rotate, or do a 180-degree rotation, which is also allowed. So what do we do in this case? Let's hold one group fixed. We need to put hydrogen on the top. Yeah. Okay. So the amino group is held steady. So let's hold this steady, and then we rotate either clockwise or counterclockwise reasonably, so that the lowest priority group is at the top. If we do that, remember the amino group is held steady, and then of course we should rotate clockwise. So hydrogen replaces bromine. Bromine replaces, remember, amino group is held fixed or steady. Bromine replaces the methyl group. The methyl group replaces hydrogen. And if you look at this now, of course, bromine is number 1. An amino group is number 2. The methyl group is number 3. The hydrogen is number 4. If you check the rotation, it's actually counter clockwise, and therefore this is S. So this is the absolute configuration of this Fischer projection. Follow this technique, if you like, or this method of holding one group fixed or steady to start with, and then doing a rotation either clockwise or counterclockwise for the lowest priority group to be at the top. And then, of course, we check the rotation afterwards. Another possible rotation is 180-degree. So let's do a 180-degree rotation and then see what we get as a result. If you do 180-degree rotation, of course, groups swap positions. So what we get is the methyl group up, bromine down. Remember, these two vertical groups swap positions. We get amino group here and amino group, and hydrogen also swap positions. So we get the amino group on the left, hydrogen on the right. And remember, bromine has the highest priority. Amino group or nitrogen has the second. Carbon number 3, hydrogen number 4. Okay, so we did this, and then we, of course, number 4 is not at the top, so we need to hold one group fixed or steady. So what we can do is we hold again this amino group steady or fixed, and then obviously we rotate counterclockwise, and if we do that, then we get something like this. So hydrogen here, remember the amino group is in exactly the same position because it's held fixed or steady. So hydrogen replaces methyl, methyl replaces bromine, and bromine replaces hydrogen. Remember, this is number 1, that's number 2, this is number 3, and that's number 4. So if you check rotation now, it's 1, 2, 3. So therefore it is also S. So this is actually good because it can be done, or this determination of R and S configuration can be done either way. You can go straight to holding one group fixed or steady, you rotate, and then you check rotation if it's clockwise or counterclockwise. Or you can do 180-degree rotation, and then you do the same exercise. Whichever is faster can be done. This idea, or this practice, if you like, of RNS configuration can be done either way. Clearly, in this case, the first method is actually quicker or faster, okay, because it's more direct than the second one. So this serves as another example, or another practice example, if you like, for the determination of the absolute configuration on or of a Fischer projection.